Hello and welcome. I would like to show you the capabilities of FancyPars. So here you can see FancyPars grammar. This is actually the grammar for FancyPars itself. For the this is the grammar for the grammar definition language that FancyPars uses. Um, I think this char range should be marked internal. Internal. Yes. This car range is internal. Okay. And yeah, just so you can see this. I will write out the AST that thing generates. I know this thing here is static immutable. Static immutable means that it is there at compile time. The genAST function is a function called on this value, on the result of parse of lex, parse, and then this. Okay? So, this is parsed at compile time, and it is analyzed, and an AST that will be stored in this AST underscore variable is also created at compile time. Now let's see what we get when we start this. And you can see it takes some time to build, and this is what we get. We have a class called identifier. It has a car array with identifier. We have an abstract class stnode. We have a class group that has an identifier name and an identifier annotation, group array groups, and pattern element, array elements, and whoops! I just have found a bug in the generator. It does not do the inheritance here. This group should inherit from AST node because you can see it is nested in there, right? Okay. So let's fix this. And yeah. Where is it? Class. And we have, of course, the inherit from parent group dot name dot identifier. Now it should generate the correct AST. Yes, you can see now the class group actually inherits from AST node and then get defined. The identifier inherits from AST node. The abstract class pattern element inherits from AST node. The alternative element inherits from pattern element. Parent element inherits from pattern element, and so on and so on. This named car is actually electro element and inherits from electro element as it should. Not element, look behind element, range element. Those are all the electro elements and they all inherit from the right base class now. Okay. Well, as you can see, this thing here, this is generated at compile time, right? All of this is generated at compile time from this source. Oh yes, and I had my other compile time test enabled, which parses this input. Those are roughly 8,000 lines of this grammar definition. It is always the same grammar definition repeated. I don't have any syntactic checks in there that would prevent the identifiers from being defined twice and such. So all of this gets parsed in when I do this. When I click on this button to compile, then all the 128k here, this is 128k on the drive, gets parsed, and then the AST gets generated. So I now comment out the parsing of the 128k. Click on the compile button, and you see it is there immediately. As soon as I command this in, say this is in, right? Click on the compile button, and it takes much longer. As you can see, it takes much longer. Right. This is actually the biggest input you can do with my parser at CTFE. If I add this again, right? Then you will see that it should break now. It shouldn't be able to compile. Oh, it does. Alright, we have to add a bit more. Okay, I just let's paste it 3 times. So now this should work. Yeah, and there we go. It fails. Unable to fork, cannot allocate memory. See that? That happens when you try to parse more than 8k in my machine. Let's look at the tab here. What happens when I press the comp button? Whoops. The memory allocation goes up. CPU time is pretty much up. You can see it's away now. Let's do it again. DMD allocates memory, and when it has allocated 3 GB, it dies. Alright, if I take just a bit of that out, right? Like this. Okay, I have to take more out. Okay, now it should work again. Whoops. There. And you can see that it does not take as much memory. Alright. Turn it again, and again it takes a lot of memory, and then there it is. So now you have seen that this is actually generated at compile time, and I think this is pretty great. Okay, bye.